On the same axes, sketch the curves with the equations y equals 6 over x and y equals 1 plus x. So let's draw a set of axes. It's my x-axis. Here's my y-axis. Right, the 6 over x. I know that's going to have a vertical asymptote of x equals 0. It's going to have a horizontal asymptote of y equals 0. And it's going to look something like this. So this is my graph of y equals 6 over x. Now to draw the 1 plus x, or x plus 1, same thing. It's got a y-intercept of 1, and it's got a gradient of 1. So it's going to look something like that, intercepting here at minus 1. So that's my answer to part A. We're then told that the curves intersect at points A and B. So here's point A, here's point B. We need to find those coordinates. So we're thinking simultaneous equations for intersection. So I'm going to say that 6 over x is equal to 1 plus x. Times both sides by x. Take the 6 away from both sides. I can now factorise the right-hand side. It's going to have to be a plus 3 and a minus 2. The 3 times the minus 2 gives the minus 6. The 3 plus the minus 2 gives the plus x, the plus 1x. So therefore x equals minus 3 or x equals 2. So the x-coordinate of point A is minus 3. The x-coordinate of B is 2. And now we can work out the y-coordinates by substituting those x-coordinates either into the 6 over x or the x plus 1. I'm just going to substitute them into the x plus 1 because it's easier. So I'm just going to add 1 to both of those x coordinates. So the y coordinate of point A is minus 2. The y coordinate of point B is 3. So that's part B. We're then told point C, the curve with the equation y equals x squared plus px plus q, where p and q are integers, passes through the point A and B. Find the values of p and q. So if we've got our curve, x squared plus px plus q, and we're told that passes through point A, so we know that's going through the coordinate minus 3, minus 2. So that means I could substitute that coordinate in. I could say that minus 2 is equal to minus 3 squared plus p times minus 3 plus q. So I could say that minus 2 equals 9 minus 3p plus q. Taking the 9 away from both sides, I can say that minus 11 is equal to 3p plus q. Right, we'll pause there for a moment, because I can't go any further with that. I also know that it goes through the point B as well. It goes through the point 2, 3. So I can now repeat that process that I've just done with the coordinate 2, 3. I know that the y-coordinate is 3 when the x-coordinate is 2. So 3 equals 2 squared plus p times 2 plus q. So 3 equals 4 plus 2p plus q. Taking the 4 away from both sides, I find that minus 1 equals 2p plus q. And now we have simultaneous equations where we can work out what p and q are. So let's take those, just get myself a little bit more room here, moving those up here. If I take those away from one another, I'm going to do the bottom equation, take away the top equation, because that's going to eliminate the q's. So I'll tell you what I'll do actually. Let me put this one down here like this. So on the left hand side, the minus 1 minus 11. So minus 1 plus 11 is 10. The 2p minus 3p. So 2p plus 3p is 5p. And the q minus the q is 0. So 5p is equal to 10. So p is equal to 2. If we now substitute that back into either of these equations, I'm going to substitute it back into the first equation. We've got minus 1 equals 2 times p, so 2 times 2 plus q. So q is minus 5. Therefore, our original quadratic equation for c is y equals x squared plus 2x minus 5. That's the equation of c. Part D, add c to the sketch. So we've got a quadratic that goes through points A and B. It's going through the point minus 5 on the y-axis. Our y-intercept is minus 5. So minus 5 is, I'm going to put it roughly about here. And my quadratic is going to look like this. So there's c, there is my y equals x squared plus 2x minus 5.